All right, in this video we are going to look at the end behavior of polynomials. I am first going to look at even degrees. Okay, E-V-E-N, degree. That means the degree is like 2, 4, 6, and so on. Okay, here's a basic picture. When your degree is even, all right, if this is our x and y axis, generic polynomial, our ends will point in the same direction. Okay, so in fact I just drawn a parabola, so that means I have a degree of 2. Now here's how we know even degree, ends point same direction. Okay, so in this one it points up and up. So since both ends point up, our leading coefficient, okay, I'm going to write it as LC, has to be positive. Okay, and then the end behavior of this one, when your leading coefficient is positive and your degree is even, that means it points up to the left and up to the right. So our textbook calls it up and up. Okay, up to the left, up to the right. What does that mean? It's approaching positive infinity both up to the left. As you go to the left, y points up. As you go to the right, it points up. Now, what if our degree is still even, but our leading coefficient were negative? So LC is negative. Well, that's like your parabolas where they open down. There's our x-axis, our y-axis, so opens down like this. This would be a negative leading coefficient. Okay, well, how does our book describe this? Well, as you go to the left, it's going down. As you go to the right, it's going down. So they describe it as down and down. All right, as x gets more negative, y is pointing down. In other words, it's approaching negative infinity. And as x gets more positive, going to the right, it's still pointing down. Y is approaching negative infinity. Okay, now the other type of degrees, if the first types were even, the second type would be odd. So for odd degrees, all right, a basic picture of something with an odd degree would either be like a line, linear, or, something like we could get fancy and we could do a cubic function, like that. You notice the ends are pointing in opposite direction. Okay, now if you were to connect these ends, the line would have a positive slope. So that means your leading coefficient is positive. We have an odd degree, and if you're going to the left, it points down. As you're going to the right, it points up. So it calls this down and up. It always goes left first, then right. And our last type with an odd degree is when our leading coefficient is negative. Okay, here's my x-axis, my y-axis. Okay, so it's like this. See, if I were to connect the two ends of my graph here, I would have a negative slope. So my leading coefficient's negative. And this would be considered up to the left, down to the right. So our book calls it up and down. It's always left then right. Okay. And one more thing that's like really fascinating about polynomials is I had told you this was a quadratic, which we had graphed these in the last chapter. They're just parabolas. You notice quadratic has a degree of 2. That's what makes it even. But you notice it has one curve. All right? If you take your degree minus 1, that will equal the number of curves. Okay, also, I mean, I could write this in a different manner and say number of curves plus 1 equals the degree. All right, I told you this is a parabola, quadratic. Quadratic means we have a degree of 2. Oops, let me get my little lines off there. Degree of 2. So 2 minus 1 equals 1. We have one curve. This is a cubic function. That means our x is to the third power. 3 minus 1 is 2. You notice 1, 2 turns. Okay, 2 number of curves. So that's just a neat little fact about polynomials. All right, have fun with these.